Okay, welcome back, and this is part two of the week four EST 101. And obviously, if you have noticed, I've combined a couple of chapters from Nora book into this week material. So make sure you download the book and go over it. So we did cover the nozzle, the pump, pressure, and now we'll talk about draft and venting. And all these combination is about giving us the right amount of combustion inside the chamber and to achieve uh, no smoke state. So draft and venting, every pound of oil requires 14.5 pound of air. So this is pound by pound per weight. So totally you will get 15.5 pounds of product. I'm not really sure about this weight equations and how does it work, but just gives you it gives you an idea of how much uh, product are you going to have coming out of your boiler, and why do you need the proper amount of chimney and the amount of suction inside the boiler. I did talk about I did talk about sealed and open connections and venting. Open connection is when you take the air from the location where the boiler is installed. Sealed connection is when you have the boiler absorb or pull air from the outside and vent to the outside, which I prefer much uh, more than the open connection. However, there is a advantage to pulling air from the space because the air inside the basement or wherever you install the boiler is warmer than the air outside, and that will improve the efficiency of you burning the oil or gas. So there are advantages and disadvantages, but when in doubt and if you have an option, you use the sealed one, so at least you guarantee that the boiler will get all the air it needs from the outside. Uh, okay, having said that, draft is the suction of the air into the chimney. There's natural draft and there's torrential draft, forced draft, and direct venting. Direct venting is what I just described, which has to do with what happened here. I think I had an issue with the recorder, but we're fine now. So, natural draft is when you depend on the hot air going by itself outside the burner. Torrential draft is when you use also the pulling of the air to outside the house using the buoyancy from hot air to cold air. Forced draft is when you have an inducer fan at the end of the chimney to pull the air from the chimney. It has also you, doing so you'll have a lot of suction draft inside the chamber. It's okay, but also you might pull too much excess air inside the chamber. So it's the last resort if you cannot have proper natural draft inside the space. Direct venting is when you have the vent or the air coming inside the chamber from the outside instead of from the space where the boiler is located. Draft development, if you look at this schematic over here. So we have heavy, cool air coming from the basement mixed with the fuel, and we are performing the combustion over here, hot air by its nature, and the pressure will go outside. And this is the supplementary air because the flow of air here is very fast and it will produce some kind of a vacuum. And that vacuum, if you don't have this draft control, it will uh, cause some air to go back inside the chamber and the air will not go smoothly, and you might also force some air to the outside of these cracks over here, and you don't want any kind of combustion or flue gases coming into the house. You want to go outside uh, through the stack. And if you have ever worked with chimneys or stacks, probably you've noticed that the longer the stack, the faster the air will come to it. The more it will have this pulling power. The air will pull faster in longer chimneys. That's why a lot of industries they have longer chimneys to pull the air using natural draft instead of pushing air through it. So draft is based on pressure difference. Air will move from high pressure to low pressure. They uh, hot and cold air in a house infiltration. That's part of a draft. And we used to count on the house being drafty to pull in air for the boiler, but that's an old practice. Currently, we do not like to depend on that. And if you've noticed that the door to the basement usually have some kind of slits in it to allow air from the house to go into the basement, so the boiler can achieve good combustion. And there's a newer video that I posted for troubleshooting that you'll see probably in week 4 or 5. I'm not gonna spoil it for you, but there's a guy who actually tried to go and find the problem with the soot accumulation in the house, and he finds out that it's basically the draft alteration in the house. So look, give it some time and watch that video and see how if it makes sense to you or not. But wind does also alter the draft because it will change the pressure. And uh, what I'm trying to get at here is we want to balance the air coming inside the boiler or furnace to the air coming outside. And probably you'll see a lot of issues with furnaces and boilers where you have the hot air inside the duct system mixed with the draft air, and that's a very hazardous situation. Um, Chimneys, hot chimney and cold chimney. In a hot chimney, the hot air will rise and pull in anything with it from any of these cracks that you see in here. Um, in cold time, when the chimney is cold, the air is very heavy inside the chimney and it sinks to the bottom. Um, So if you start pumping air into it, it's going to be a little bit harder to pump air, hot air into the cold air because it's heavier. But once it goes through, it will, once it finds its own pitch and its own way, it will start to float upward because it's lighter than the cold air, and eventually it will cause the whole chimney to heat up, and it will provide the proper amount of draft. This is the infiltration that we count on to provide air and supplemental air into the boiler. And think about that when you do an installation, and think about that you don't want any completely sealed basement, because a sealed basement provide no air for combustion and provide no air for the draft regulator to work with. We did discuss that. How does it work? It's just more illustration how does the stack work into pulling air into it. When everything fails and the stack is too long or too wide, we can't achieve proper draft. And again, how do we know if there's a proper draft or not? We're gonna do a draft measurement in the over in the chamber and over the fire and on the stack to see what is the draft. Are we pulling air or not? Because otherwise we'll have some backdraft, and that means we will have CO2, possibly carbon monoxide inside the house. Draft estimation based on the average chimney temperature and height. So the chimney temperature, constant temperature, and the height will give you this amount of draft. That's really good, valuable information to know based on the air being outside is being 0. So the outside is very heavy. Let's say the chimney temperature is around 500. Your chimney height is 15. So the longer the chimney, the higher the draft. Because we said it's gonna pull more, and the speed of air will accelerate. So shorter chimney will give you less draft, and you have more draft in a longer chimney. So this is what draft you expect if you were to go and size the chimney and see if you can connect to the chimney, or maybe you should just connect to the outside directly and not use the chimney. But there's a lot of codes that goes into connection with the draft, because the flue pipe gases are very hot, around 500, which is it's a little bit too much to be pumping into the air from the side of the house without a proper chimney vent. Over here, this is chimney temperature, height in feet. So what is the difference? Let's see. Hmm. So I think, oh, this is the formula here to give you the calculation based on different temperature. So this is the case when there's 0 degrees. This is the case of 60 degrees, and this is the case of 0 degrees. Sorry. Okay, so it's case one and case two, and this is the formula to calculate based on whatever outside temperature do you have. Okay, that's a very good important formula to have and to know where to find it when you need to. Thinking about draft again, we have to think of the conservation of mass, which is air out equals air in. If you want to pull air out of the place, you have to supplement air in it. Otherwise, you're gonna have a vacuum, right? Doesn't work this way. So think about that. If you want a certain amount of air to leave the house, you have to bring in equal amount of air. Pressure difference is another thing. Cold air is heavier, yet so it has more pressure than hot air. And we need infiltration. Sometimes we want to control the infiltration. We don't want just random holes around the house. We would like to have our own mechanical ventilation and infiltration of air coming in. And we did say there's infiltration, there's exfiltration. Infiltration coming inside the house, exfiltration is going outside the house. So we need the right amount of air coming in and out, especially if we're going to do combustion and we're burning a lot of air. So think about it. If we are burning 1 gallon, that's in an hour, 1 gallon per hour, we need 15 equivalent. I don't know what's the in volume. I think it's a little bit different, but if you let's say 1 pound of oil, which is going to be maybe 1/8 of a gallon. So you will need to have, so 1 gallon is about 8 pounds, 7 pounds. So 7 pounds, I'm going to try to do the math in my head. 7 pounds will give you around 7 times 15 or 14 pounds. So roughly around, you need 200 cubic feet of air to come in for an hour inside the the basement. So go back to the equation, look at it, and think about how much air you need to bring into the basement before you put in that boiler. And in some cases, you see actually basements with open windows and open space, and that's in purpose to provide air for the boiler. Excessive draft. If you have excessive draft, that will increase the combustion air. That's why we have a damper and a draft regulator. You don't want too much air coming into the system, because as we said, like as the air moves through the chamber, it will provide a lot of negative pressure. So if you have holes in the chimney, it will pull in a lot of air, and that's why we have a draft regulator to manage how much air goes in there and to maintain the pressure inside the chamber. So that's the purpose of the draft regulator. It will close if there's no pressure, and it will act based on the pressure and the flow inside the chimney. This is a draft regulator. It's called a swinging door as well. It has a weight here to close. This weight will close the door when there is no flow, and it will open slightly when there's flow inside the chamber, the flue pipe. This is how we measure the draft. This little machine here will measure the draft based on pulling on air from this tube. This tube actually is made out of metal because you're going to stick this into the combustion chamber. So over the combustion chamber should be between 0.1 to 0.2. So between here and here, that should be your draft. And from here to here, that's minus. And over the breech, it should be from 3 to 7. Minus 3 to 7. So 0.01 to 0.02, it should be around here. And from over the breech, it should be between 0.3 and 0.7. So it should be somewhere, it's minus, so it should be somewhere around here. We'll do that when it comes to combustion testing. Chimney sizing. As a general rule, they say you should have 1 square inch of chimney size per 6,500 BTUs input and not less than 8 diameter. So this is again another good piece of information to have for the oil burn technician license test. So for 6,500 BTUs, you need 1 square inch. So for so let's say you have a 30,000 BTU, you're gonna divide that by 6,500 and see how many inches that gives you, but not less than 8. So you're gonna start with 8. No matter even if this calculation turns out to be 6, you're gonna put 8. 8 is the minimum. It can only go higher. Okay. When the flue pipe is replaced, make sure it is the same size. Uh, if try, if possible, try to use 45 degrees elbows. Try to avoid using 90 degrees elbows because they do hinder the flow a little bit and they provide a bottleneck for the flow. Draft regulator should be at least 10 to 12 from the primary control. So that's because, again, it's going to pull in air. You don't want that pulled air coming very close to the primary control because that's going to offset the operation of the primary. It must be 18 inches away from the combustible wall, from any combustible material wall. That is the draft. Uh, and the chimney, the draft, the chimney outlet, the draft, and the flue pipe should be away from the primary control and should be away from any combustible material because it gets hot. The average temperature of the flue pipe is around 450 degrees Fahrenheit. Chimney sizing again. It's another chart. And this is the connection if you have two uh, boilers, one for heating and one for water. And this is something called the Y connector. So another question that I found in the oil exam is how do you connect two pipes? You use a Y connector. It's called a Y because it's not like going straight. It's done 90 degrees. It's kind of using 45 degrees to ease the flow of that connection into the chimney with an angle to give the flow more direction upward. This is another stack, and this time it is separated. And usually when you have two stacks and two connections to the chimney, this is a good actually best practice technique, is you put the smaller stack on the top. The flow from here is going to be a little bit higher. You're going to get more flow than the smaller pipe. That makes sense, right? So if you switch them and put the small one in the bottom and the big one at the top, you might have a backflow based on the energy density, and probably the water here is not going to run as much as the boiler. So you want the flow that has more heat and no continuous burn to be in the bottom, not on the top, to prevent backflow. And again, it has to do with the size. So the larger the firing appliance should be below the top one. Okay. Chimney check. When you do your annual inspection, you should always check for debris in the chimney, open it up, and look inside with a flashlight and make sure there is no residue. A white residue tells you that there's something wrong with the combustion, and there's the presence of maybe more sulfur in the diesel than it's supposed to, and it should be cleaned. If there's a lot of soot, you also try to clean that because accumulation of soot only exacerbate the problem of more soot coming in. Do a draft test, inspect the pipe for damage, make sure they are connected, put some duct tape if possible. For duct tape, try to use something with heat resistance to seal all the openings in the pipe. Check the chimney from the outside for any obstructions. I know it's a little bit of a boon to do that, to go all the way to the chimney in the top and look at it, but a lot of things falls into the chimney. They do have a mesh in it, but birds tend to live there and they keep stuff. So you might want to go and check that it's not obstructed and there's nothing preventing the air from flowing outside. Also look for water condensation. That's a very important tip. If you have water condensation inside your chimney, that means the chimney is not hot enough. And that condensation probably has a lot of sulfuric acid in it, and it will eat and deteriorate your chimney and your boiler. So if you find some condensation, that means the the flue pipe gases are not hot enough. So you have to go check the chamber and check the combustion and make sure it is at least 450 degrees Fahrenheit. If it cools off, you're gonna have condensation and you're gonna have to burn it a little bit higher, and probably you have to consult with the manufacturer to see what is to do to increase the temperature of that chamber. Here are some guidelines about where do you end these vents if you don't have a chimney. So this is the minimum requirement to have these vents. So usually away from the grass, away from any opening, at least like what does it say here? 4 feet below a window, because again, hot air will rise and you don't want that to go into the window. So if it's pointing downward and it's away from the window, it will spread in a different way, and not, you didn't get a lot of gases inside the window. And if it's going to from the top of the window, it should be 1 foot, and this is according to NORA. And then you gotta check the regulation for your town, and the CMAR for what is the chimney termination from any opening in the house. I know it's from any opening it should be at least 4 feet, but there's different guidelines for where can it terminate, if it's the top of the window or below the window. So make sure you review the CMAR for that information. More distances and clearances for vent and vent hoods, and this is actually from the CMR, and it addresses the clearances of the boiler from the walls based in the chimney and distances. So look at this. So if you look at this D, these are the forms type of the appliances. You look at them, you have to look for the boiler for those appliances. I think they are rated based on the size. So if you have this size, let's say uh, form A, it has to be, A is the distance from the top. I don't know what they mean by 2 square. In 2 square 4. I'm not really sure, but it's in inches, I believe. And if you look here from the front, this is like a side view. It should, from the other wall, it should be 2 feet. I think this is inches, 2 feet. And C is a chimney from the top, should be 18 inches. And from the other wall, it has to be at least 6 inches. If you have the space, try to like make it a little bit accessible, because at some point somebody will have to go and service this boiler, and you don't want to deal with very, very narrow and tight spaces. So please look at the carbon monoxide issues and in the video that I'm going to post on the Blackboard. And these are some notes that I gathered from the video. I hope you look for these as the person in the video talks about them. The whole thing is trying to educate you about carbon dioxide and why is it very, I mean, carbon monoxide, and why is it very important to prevent against it, because it is very dangerous and it has no smell. And since we are doing combustion, we have to be aware of that, because one of the main reason of carbon monoxide is combustion. So look at these notes and watch the video, and hopefully you got to register all of this information. And I will make sure to post the video on Blackboard as well. All right, thank you. I will post this video and put any questions you have in the discussion board, and I'll see you in the Hangout.